mirrors. And before that, we talked about mirrors. And now we're going to talk about lenses. And then tomorrow, we're going to talk about lenses. When we talked about mirrors, we started by talking about mirror ray diagrams, and then we talked about mirror equations. Well, today we're going to start by talking about lens ray diagrams, and then we're going to talk about lens equations. To get started, you need to know that there are two different types of lenses that we are going to study in this class. The first type is a lens that looks like this. Now, this is very hard to see from your particular angle looking through a computer screen. But here's what you should be able to see, and you can definitely feel it if you can feel this kind of lens, is that this is a kind of lens where the sides are kind of bowed inward a little bit, so that the center is a little bit skinnier and the edges are a little bit fatter. Now, here's what I want you to do. I want you to take a look through this lens, and I want you to tell me, when you look through this lens, what kind of image do you see? Did you say that you see an image that is upright and reduced in size? Interesting. This is one type of lens. Here's another one. This type of lens is different from the other one. It's skinny around the edges and it's fat on the centers, so it kind of bows outwards like this. This other one here, you can even see the difference between the two of them when you hold them up side by side. Can you see that this one is fat on the edges, skinny in the center? This one's skinny on the edges and fat in the center. This second type of lens, the ones that's skinny on the edges and fat in the center. Now, here's what I want you to do is I want you to look through it. Haha, there's me. What kind of image do you see? Give a nice description. What descriptor words would you use to describe it? Okay, now we're going to try something different, and I'm going to see if I can make this work because I have no idea truly if it will work. Okay, here's what we're going to do is I want to see here if I can get you to look at that, and this really might not work. Okay. Yes. Okay, perfect. Hey, can you see? Oh gosh. Well, I said perfect, and then I meant not perfect because Miss Wilson needs to work on aiming. Can you see my little computer screen all the way over there on the other side of the classroom? Look, there it is in real life. There's my little computer screen all the way on the other side of the classroom. This is the exact same lens, but what kind of image are you seeing right now? Did you see that you're seeing an image that is inverted and reduced in size? Turns out these little guys, these little types of lenses, can make two types of images. We're going to talk about both of these types of lenses today, and we're going to draw some diagrams to see how they work. Today we're talking about lens ray diagrams. Take a look. I'm going to move this down to the bottom. Okay, take a look. Lens ray diagrams. When we draw lens ray diagrams, we will always start the same way that you always started when you drew mirror ray diagrams. And the way that we start is we start by drawing our principal axis. Now you are going to want to do this here with a ruler. This is very hard for me to do with a ruler, as you've known and seen in previous episodes of Miss Wilson trying to make videos with a ruler but not being able to. But I'm going to do my best here. We're going to start by drawing our principal axis. I'm going to change my color here. Let's make our principal axis blue. Okay, here we go. We're going to start by drawing our principal axis here. Oh gosh, okay, I can do it. Okay, undo. You're drawing this, oh, nope, redo. You're drawing this on your piece of paper here. I'm going to draw it right here. Here's my principal axis. Okay, not too bad. Now what we're going to do next is we're going to draw, and this is going to be different than our mirror ray diagrams, but we're going to draw a line through the center here of our principal axis, and I want you to draw just a nice dotted line through the center. Using your ruler to keep it nice and straight. I'm trying to use my ruler here and it's kind of working. We got medium level of functionality, people. That's not too bad. Okay. Pretend that's straight. Now what we're going to do is we're going to draw our lens. Now when you draw a mirror, you do need to use your compass to draw a curved mirror. For our lenses, we don't need to use a compass. We can just actually kind of freehand this thing. So here's what I'm going to do is I'm going to start with our first type of lens here. And the first type of lens that we're going to draw is a type of lens that you actually saw second just now when I showed you both lenses. This is what we call a convex or a converging lens. Now some of you, as you're writing this down, a convex or a converging lens, you're already freaking out a little bit because you say, wait a second, Miss Wilson, we just did mirrors. And when we did mirrors, a convex mirror was a diverging mirror, and a concave mirror was a converging mirror. It's flip-flop for lenses and mirrors. The reason for that is because the first word describes the shape of the lens. This lens is a convex lens because the two sides are bowing outwards like this. And anything that bows outwards, we call that convex. So the first word describes the shape. The second word describes what it does to light. A convex lens is a lens that can converge light to a single point. Let's draw a picture of this kind of lens. The way that we do it is we call this here the center of our lens, and actually I don't like this here because I feel like even though I used a ruler and I tried my darndest, I feel like somehow it still ended up not straight. How did that happen? I don't know, so I'm gonna just try it one more time. So here's what we're gonna do is we're gonna start by looking at this convex lens, and the way that we're gonna draw this, let me see how I can do here. Okay, stay straight, everybody. Stay nice and straight. You can do it. Dotted line all the way down, just like this. Oh, again, that is not what I wanted to do. This is why the ruler situation doesn't work. Okay, take two. I believe I can do it. I still believe. Okay. Here we go. Oh, gosh. Okay, take like 17,000,001. Here we go. This is where you guys say, Miss Wilson, just please give up with the ruler already. I get it, but I just want it so bad. I just feel like it's gonna work. Okay, that I feel decent about. It's not great, but whatever. Okay, here's how we draw a converging lens, a convex lens. Is we're going to draw on each side the shape of a lens that is kind of bowing outwards like this, and kind of bowing outwards like this. Ideally, if you drew this really nicely, which I did not, then you should get the fattest part of your lens should be here, kind of at the center line, and then the skinniest parts of your lens should be on the edges, but mine is kind of like halfway decent. Okay, here's what we're gonna do next. Every mirror, you know that every mirror has a center line and a focal point. Well, the same thing is gonna be seen here with lenses. This right here, this little dot that I'm drawing now, this is the center of your lens. Go ahead and label it C. And every mirror is going to have, or every lens is going to have two foci, two focal points. A mirror has one focal point because it has one curve, but a lens has two curves, so it has two focal points. So here's what I'm going to draw, is I'm going to draw on either side a certain distance away from my center, my two focal points. Now we'll see how this goes here. I'm going to draw one. Here's my center. Okay, right there's my center. I'm gonna draw each one on my piece of paper. Let's see, I'm gonna go 1, 2, 3, 4. I'm gonna go 4 centimeters away on this side to draw here. And then on my other side, likewise, I'm gonna go 1, 2, 3, 4 centimeters away on this side. Is that right? Wow, let me try again. 1, 2, 3. Oh, maybe I like 3 centimeters away. I like 3 centimeters away. Okay, I'm gonna go 3 centimeters away on either side. You do what works for you on your piece of paper. I say for a general like piece of notebook paper, normally like 2 centimeters is a good amount. Now we get 2 focal points, one for each curve. I'm going to label this one F, and I'm also going to label this one F, but I'm going to call this one F' prime. Otherwise, if I call them both F, then it's going to get really confusing here in a second when I say, now draw a line pointing through F, and you're going to say, which one? And you have a whole panicky kind of moment. So we'll draw it like that. And now let's draw an object. We're going to start with an object really far away from our center line here. Okay, now we follow our 3 golden rules. Our 3 golden rules for mirrors apply to lenses also, but we just tweak them slightly. See, when it comes to mirrors, mirrors work by reflecting light. When it comes to lenses, lenses work by refracting light. They bend light. So when we talked about mirrors, we talked about how a light ray that goes through F will get reflected parallel to the optical axis. Well, now we'll talk about how a light ray that goes through F will get refracted parallel to the optical axis. Mirrors reflect, lenses refract. Let's go ahead and take a look at our very first sort of situation here. Okay, wait, let's see. So this right here is going to be the top of my object. Here's me trying to use a ruler again. Again, just say, Miss Wilson, no, don't do that, please. It's miserable when you try to use a ruler. I know it's awful when I try to use a ruler. Okay. And then this one goes right there. Okay. I think I got my ruler set up. Okay, so we're going to see how this goes. No idea, truly, how this is going to go. Oh, it's not set up. Okay. It's not gonna work. It's not gonna work. Okay, I give up. I give up with the ruler. Okay, I hear your calls and I hear you saying, Ms. Wilson, please give up with the ruler. I'm giving up. Okay, it's all over. No more ruler. Let's try our first golden rule. Our first golden rule for a mirror was that a light ray that passes through C will reflect back on itself. Well, here our rule is that a light ray that passes through C will continue on unrefracted. So we draw, you do this with a ruler, you set up your ruler so that it starts on the top of your object and then just slides straight through C like this and goes back down on the other side. Really, I did a bad job here because my line should cross perfectly through C. Precision is the name of the game with these kinds of light ray diagrams. So please draw yours nice and precise. Lovely. Next, that's our first rule. Our second rule is going to be that a light ray that passes through F is going to refract parallel to the optical axis. Now, we have 2 F's here. Which one we use depends on whether we have a convex or a converging lens or a diverging lens. So I'm going to start here. A light ray, this is our second rule, a light ray that starts on top here is going to pass down through F prime and land right here at the center line. But once it gets to the center line, it's not going to keep on going through, no, because this whole little lens situation is in the business of bending light. So it's going to bend light and it's going to travel off parallel to the optical axis like so. Although, of course, you drew this with a ruler. And when you drew it with a ruler, you drew a nice straight line, unlike my wonky bad lines right now. Something like that, okay? It's not great, but we'll let it be. That's my second rule. My third rule looks like this. We said with mirrors that a light ray that was parallel to the optical axis reflects through F. Well, in this case, we're going to have a light ray parallel to the optical axis will refract through F. Let me show you what it looks like. We draw a light ray that is parallel to the optical axis like this, except mine is not very parallel, but you get the idea. A nice parallel line to the optical axis. Then when it hits the center line, can't keep on going straight because lenses are in the business of bending stuff. It's going to bend it straight down through that second focal point right there. And again, I could just do a little bit better and I get too perfectionistic. And Miss Wilson, just let it go. It's fine. It's a video. Okay, yes, got it. Nailed it. Oh, it's perfect. It's lovely. And here's what we're going to see. Before we try to talk about what kind of image we're going to see, here's a question that you need to answer is, where would your eye be in this sort of setup? Your object is over here on the left-hand side of my screen right now. Your eye would be over here on the right-hand side of the screen. Because when you look at an object through a lens like this one, you can see right now your eye is at the camera. That is right. Oh gosh, I got a touch screen. Oh my, Gosh. I just am so embarrassed here. Okay, don't worry guys, I'm recovering from my embarrassment. Here we go. Okay, your eye is right here at the camera. That's where your eye is. The object is my face. It's over here. Hey guys, what's up? The object is over here. Do you see that your eye looks through the lens to see the object, which is on the other side of the lens? And so, if we go back over here to our drawing, your eye is on the opposite side of the lens. It looks back through the lens to see the object. When your eye sees these light rays, it's going to see this light ray right here, this light ray right here, this light ray right here, and it's going to say, where do those light rays come from? And it's going to trace them back, and it's going to say, oh, I get it. They all seem to converge right here. This must be the convergence point, and you're going to get a little image right here. What 3 adjectives would you use to describe this image? Well, you would probably say this image is inverted. You would probably say this image is reduced in size. And lastly, this image is made of real light rays. There are real light rays that are actually here. So you would say that this image is real. This is exactly what you saw when we took our little camera sort of set up here, and I showed you a picture of my computer through this little lens. What you see, wait. Okay, there. Wait, oh. Miss Wilson, get better at aiming. I'm trying. Okay, what you see through this little lens here is you see a little picture of that little computer. That computer looks upside down, it's inverted, it's reduced in size. And that right there is actually a real image. There are light rays that actually pass straight through this lens, come out on the other side, and make a little image in front of the lens. That's our first type of image that we get with one of these types of lenses. But there's another type of image that you get with one of these types of lenses. If the object in question is very close to the lens, then you get a magnified image. Let's go ahead and take a look. I'm going to get out a brand new drawing here. This is still the same type of lens. It's still a convex or a converging lens. But now we're going to draw things slightly differently. So once again, I'm going to start by drawing my optical axis, and you will too. I'm going to start it right here, nailing it. And then after that, let's draw a nice center line here for ourselves. Oh, no, I'm not doing it. I'm doing bad. Okay, here we go. 1, 2, 3. Nailing it. Yes. So much success right now. This is so super awesome. Miss Wilson can use a ruler. Okay. And now when we draw this lens, we're going to draw it kind of bowing outwards on each side like this. And then, I don't like those. I'm going to try one more time. Bowing outwards on each side like this. And then we're going to mark our center point here. Once we mark our center point, you're going to measure the 2 focal points. The 2 focal points are going to be the 2, okay, yes, perfect. They are going to be the 2 focal points on either side, and they're going to be the same number of centimeters away from each other on your piece of paper. So I'm going to count 1, 2, 3 centimeters over here, and this is where I'm going to place my little focal point. There's one of them. Then I'm going to go back to here, and I'm going to count 1, 2, 3 centimeters over here, and that's where I'm going to place my next focal point. I'm going to call this one on this side F prime, and I'm going to call this one on this side F. We're going to do the same setup here. We're going to draw a little object, but this time let's draw the little object very close to C, something like right here, inside of the focal length of the lens. Now we follow our 3 rules. Let's start with rule number 1. Rule number 1 is that a line that passes through C is going to just keep on going. So I start at the top of my object here. I go straight on through C in a nice straight line. Rule number 2 is that a light ray that's going to go through F is then going to refract parallel to the optical axis. Okay, well in this situation, when I line up my light rays, what you're going to see here is that I think I used green for this one. I'm going to line up my light ray so that it's lined up so that it would pass through F prime, but it's not actually going to pass through F prime because all light rays start on the top of the object. So it's going to start on the top of the object. It's going to be nice and lined up with F prime. It'll start on the top and head up towards the lens. When it gets to the top of the lens, then it will refract parallel to the optical axis, like so. Finally, our last rule is that a light ray that passes or that goes parallel to the optical axis will refract down through the focal point. So I start with a light ray that's headed parallel to the optical axis. It will then refract down through the focal point like this. Your eye, in this case, is sitting over here on the other side of the lens is the object. They're sitting on opposite sides. And your eye is going to see this light ray, and this light ray, and it's going to say, oh my goodness, where do those light rays come from? So interesting. Your eye will say, I see no place where they're all converging on this side. So your eye will say, I've got to trace them back. And your eye will trace each of these light rays back. First, it'll trace back this light ray, and it'll say, okay, this light ray up here at the top seems to come from somewhere like back here. Of course, you're doing this with a ruler, so yours looks nice and straight and beautiful, unlike mine. It's just absolutely stunning and rulerful. Then, your eye will say, oh, I wonder where this light ray came from. And you'll say, oh yeah, it looks like it came from somewhere like back here, maybe? I don't know. And then your eye will trace this light ray back, and again, this is where I really need a ruler here because it would make everything so beautiful. But that's okay, it's fine, it's really fine, don't even worry about it. And it would trace this light ray back and say, oh, it looks like it came from somewhere over there. Now here's why this is really bad, and this is why you need a ruler, and you've already learned at this point that precision is the name of the game when it comes to these diagrams, because if it's not very precise, then it won't get lined up here nicely. And they really should all get so super lined up where you look at it and you say, oh yeah, baby, they are all coming to the same spot, but look at mine, they look like a disaster over here. We'll try one more time. Let's switch it up. Let's put it on the pen. We'll try purple. This is going to be like the fake it till you make it kind of lesson where I'm like, oh, look, see, they all kind of line up, but I finagled it a little bit. You won't have to finagle it because all of your things will come and line up perfectly to this point. And here's what your eye will say. Your eye will say, oh, I see where they all come from. They all come from a point back here, back behind the lens. And your eye will say, I see an image, and it looks like it's right here. Now mine just so happened to land at F prime. That's not like normal or typical that you always get it landing. Like that's not a general rule that you should follow. I mean, it's totally fine for it to land at F prime. That's just not a general rule. But so you see that mine landed right here, and we could use 3 adjectives to describe this image. And if we were to use 3 adjectives, we would say that this is upright. This image is enlarged in size. And finally, this image is a virtual image. It is not the case in real life that these light rays are actually tracing back to form this image. That's not what's really happening. That's not like the truth of the matter. The truth of the matter is that your eye traces these light rays back and sees them converging at this point. But there aren't real light rays that actually go back here. It's just what your eye thinks that it sees. These are virtual light rays that form this image back here. That is a converging lens. As you can see, a converging lens can do 2 types of images, and you saw this at the very beginning of our video here. It can make things that are small and inverted, but also if your object is very, very close, then you can see it acts like a magnifying glass. Hey, what even is a magnifying glass? It's just one of these. It's a nice converging lens. That's all that a magnifying glass is. Now we call a converging lens a converging lens because it has the potential to converge light. If you look back at our first diagram, you can see that you have all of the light rays converging in one place. This lens has the ability to do that. This is the kind of lens that you can use to make fire. You know that you do this in the summertime. You take a little magnifying glass in the summertime, take a little leaf out here, put the sun back here up in the sky. Sun's far away in the sky. what happens is the light from the sun, which is an object very far away from the lens, comes through the lens. When it gets to the lens, it all bends and it all refracts to a very specific point. You can concentrate the light of the sun. You can convert the light of the sun to one specific point in space, put a little leaf right there, that's at that spot, and you got all the light of the sun converging in one location. That leaf will set on fire and it will burn. The next type of lens that we're going to look at, can't use it to set anything on fire, actually. This is what we call a diverging lens. Oh gosh, well, okay, I think it's working. Okay, a diverging lens. This is our second type of lens, and it's a diverging lens. We call this a diverging lens or a concave lens. A concave lens, concave describes the shape. It's a lens that has two sides bowed inward like this, and it's diverging because that's what it does to light. It diverges light, it spreads it out in all directions every single time. Let's draw a picture. Here I'm gonna set up my optical axis here like so. Okay, let's see how we do, and very nice. Very long optical axis, but that's okay. Now, once again, we're going to draw a nice line here through the center. Okay, if I can get my little pen to work, that would be just so superb. Okay, here we go. A nice line through the center like this. And now I'm going to set up my little diverging lens. And the way that I'm going to draw it is I'm going to draw on both sides. I get a little cave in on this side and a little cave in on this side because it's a diverging lens. Here you can see that the ends are a little bit thicker than the center. And we'll call our little center point here C. Now C is right here, and here's what I'm going to do is I'm going to measure on each side of C. Okay, here's my C right there. I'm going to measure over 1, 2, 3 centimeters because that's what works on my paper, but you might want something different depending on your paper. And then I'm going to measure back from here 1, 2, 3 centimeters, and I'm going to put a little dot right there, and those are my 2 focal points. Once again, the actual distance, like in real life, the actual focal length for a lens depends on the exact shape of the lens. But for here, all that it matters to know is that these 2 focal lengths are going to be the same on either sides for the type of lenses we're looking at today. I'm going to once again call this F prime. I'm going to call this one F. And let's take a little object and let's set it right here. And we are all good to go, ladies and gentlemen. Your eye is going to be over here ready to receive some incoming light rays and see what it can see. Now, we are going to follow the same 3 golden rules of optics. The only thing that's different with diverging lenses versus converging lenses is that when you have a diverging lens, you're going to take whichever F you used from converging lenses and you're going to flip-flop it. So if the last time with a converging lens we started by going through F prime, this time we'll start by going through F. If on the last one we ended by going through F, this time we'll end by going through F prime. So whatever we did last time in terms of whether we used F or F prime, we flip-flop that completely for a diverging lens, and that's the only thing that's different. Let's start with our first light ray. Our first light ray is that a light ray through C will continue on its merry way unimpacted by the lens. So we're going to start by drawing that here. I'm going to draw a light ray that starts on the top here, goes straight through C without a ruler, but you did use a ruler so that your line doesn't look like mine. Oh, I'm so dissatisfied. Miss Wilson, just relax. It's not a big deal. But I can't. I have this little perfectionist inside me that just wants all the lines to be straight and beautiful and going where they're supposed to be. Hey, I get it, but you got to let it go sometimes. Okay, I'm trying. Okay, there we go. There's our first one. Now let's talk about our second one. Our second rule is that a light ray that passes through F will refract parallel to the optical axis. I'm going to draw this one now. Last time when we did this with a converging lens, we did a light ray that passes through F prime, then refracted parallel to the optical axis. This time I'm going to do a light ray that's on its way towards F. Is going to refract parallel to the optical axis. So when I do this with my ruler, I line up my ruler so that my ruler is touching the top of the object and touching through F over here. And then I'm just going to draw a nice line straight from the top of the object down, straight from the top of the object down through F like this, and that's like okay. Except it's not going to make it all the way to F. Here's what's going to happen. It's going to be on its way to F like this, and then when it gets here to the center line, it's not going to make it to F. It's going to refract and bend straight off to the side this way, parallel to the optical axis. That's rule number 2. Let's try rule number 3. Rule number 3 says that a light ray that's going parallel to the optical axis will then refract through F. Well, we're going to start by drawing a nice light ray parallel to the optical axis here, except mine was bad, and I just am going to do it one more time, I swear, then I'll be done. Okay, parallel to the optical axis, like this. Now, last time we refracted down through F. This time for a diverging lens, we're going to refract up at an angle such that it would pass through F prime if it could. Now this is a weird thing because it's not going to go back down through F prime. It's going to keep on going on its merry way through the lens, but it's going to go up at an angle such that if it did go backwards, it would go back through F prime. And that's our setup. Now our eye sees 1, 2, 3 refracted light rays, and it says, oh wow, that's so interesting. I wonder where they all came from. And so your eye starts to trace it back. It looks at this light ray that passes through C here, and it says, well, it looks like this light ray came from like back here-ish somewhere. Which is true. Now that one's not very interesting to look at because it is like refracting back on itself almost. We talked about how it reflects back on itself. This one traces back onto itself when we look back at it. The next one is your eye's gonna look at this one and say, oh yeah, I wonder where this one came from. It looks like it came from somewhere back this way, like so. Interesting. And then your eye's going to say, oh, what about this purple light ray? Oh, interesting. It looks like it came from somewhere back this way, like this. And again, if I had my rulers, and it would all line up so nicely, and this one wouldn't be crooked, but I'm going to like move on and just ignore the fact that I don't have a ruler. In case you haven't noticed, I'm slightly frustrated about the fact that I don't have a ruler. Okay, then your eye would say, well, it looks like all of those light rays converge right here. And your eye would say, wow, I can see this little image right here. It looks like an image that could be described by these 3 adjectives. We could call it upright because it's right side up. We could call it reduced because it's smaller. And lastly, we could call it virtual. There are no real light rays back here. Like these light rays don't actually go back here. Your eye just traces them back and imagines that if they came from somewhere, they would come from back here. And so that's what your eye sees. And that's what we saw in our little example here when we actually looked at a real life diverging lens. When you look at a real life diverging lens here, like this one, you see that here's your eye, whoop, right there. Here's your object, hey, how's it going? And when you look straight through this thing, you can see that this image, wow, this is actually crazy as I look at an image of an image that then comes back. Oh wow, this is just, I'm having a trippy moment over here. Anyway, try one of these with a mirror sometime, it's really fun. Okay, sorry, back on task. What you see right now is you see an image of my face, hello, that is much smaller in size, it's reduced, but it's still upright. And that's what we always see with any diverging mirror. Lens. Any diverging lens. All diverging lenses always make the same sized image, or always make the same type of image. They always make an image that is reduced in size, that is upright, and that is virtual. Every single time. And so, today we've talked about the 2 types of lenses that you can see. We got diverging lenses, which are concave lenses that look kind of like this. And you can see that they always make images that are upright, reduced, and virtual. Then we talked about convex lenses, which are also called converging lenses, and they can make 2 types of images. One of these types of images is an image where all the light rays converge and you get a image that is inverted and real. The other type of image, oh please ignore the bells, they are very lovely. The other type of image that you get is an image like this where a converging lens could actually be used to spread out light rays and you get an image that is upright, enlarged, and virtual, just like a magnifying glass. I hope you have a wonderful rest of your day. That's all for today, folks, and enjoy your lenses, people. Bye.